Today we're going to be talking about um, types of graphs to display. So this data set is the MPG data set, and it's the technical specs of cars. This is available through the UCI machine learning repository. Um, and in terms of the variables that you have available, um, they're everything from MPG to cylinders to displacement to horsepower to weight. Here we're interested in showing the relationship between weight and miles per gallon. Both of these variables are numeric. When you have a numeric input and a numeric output, you will typically assess that with a scatter plot. So a scatter plot is nothing more than just a graph of the points. Each dot here represents an actual observation. So this observation right here, the car was about, just a little under 2,500, maybe 2,400 in weight, and its MPG was just better than 35 miles per gallon. Okay. Um, so this type of a plot is called a scatter plot. Again, it's used to assess the relationship between weight and MPG. And what do I mean specifically by the relationship? So one key takeaway here is that as weight increases, we observe that the miles per gallon generally goes down. Now I use the word generally here because it's not true of every single comparison. So for example, this point here, it the car does not weigh very much, but its MPG is under 20 as compared to this heavier car here that's nearly 4,000 pounds, gets an MPG between 20 and 25. Um, so it's not true for every single observation, but it's true generally. So like if we were to look at a point here that's kind of clustered in the center of the points to a point somewhere here, we see that that relationship is true, and it's true for most of the points. Okay. Um, so one other way to rephrase this question is to ask the question, does weight affect miles per gallon? And we can try and answer that with a graph. Okay. Okay. Um, so what kind of conclusions can we make from the graph? Well, I said them already, but the graph suggests the weight of the vehicle increases, the MPG decreases. Okay. This is something that we're going to study later in the course, and that's called linear regression. Linear regression is going to help us to assess by how much weight affects miles per gallon, and will be our main tool in this instance. One other side note, just in terms of the comparisons, um, for instance, I said this comparison of a low weight to this comparison of a high weight, we did not see a decrease in miles per gallon. That could be due to the fact that there are other variables that affect the outcome that aren't captured in this graph. So, for example, uh, the car could lack horsepower, right? Um, there could be, they could have too few cylinders, right? So there's other things that could affect MPG. It could also be just due to the randomness of the observation. So there's two possible sources of variation. It could be due to some other variable, or it could be due to random chance. Okay. Um, so in terms of what we'll study later in this course, we'll study how to model this data and to assess how well this red linear regression line models this black data, okay, and the points that correspond to it. We can also discuss how we could improve this. So all things that will come later. Um, thinking about just our data collection, what type of data are we dealing with? Well, that's called the design of experiment. It also affects what kind of conclusions we can make. So remember, there are two types of data collection. Data is a designed experiment if observations are randomly assigned to inputs or treatments. In this instance, based on the results of the statistical analysis, the results would be said to be causative, meaning the inputs cause a change in the output. Um, if the data is observational, there's no attempt to assign the observations to inputs or treatments. And uh, in this case, based on the results of the statistical analysis, our conclusions can only be said to be correlated or associations. So what type of conclusions can we make based on this data? Well, that depends on the design of experiment. Because we're not assigning cars to have a specific weight, we're just observing the outputs. Um, our conclusions are restricted to observations, are restricted to correlations and associations. Okay. Um, in terms of hypothesis testing, that's asking what's the big question that this graph is asking? That would be that researchers are wondering if the weight of the vehicle affects the miles per gallon. In this case, in hypothesis testing, you always have to specify two things. One is called the null hypothesis, the other is the alternative hypothesis. The null hypothesis is a statement of no effect or equality. Okay? In this case, it's that weight does not affect miles per gallon. That is a statement of no effect. The alternative hypothesis is that weight does affect miles per gallon, and that's a statement of an effect. That's the alternative. That's what you want to establish, or a statement of inequality. Okay, and you'll have more examples of this later on. Um, we will come up with other ways to assess this, but just based off of this graph, it does seem like weight plays an effect in the miles per gallon. Okay. Thank you very much.